Hello students, I am Kausalya. Today we are going to solve example 1.11. The problem is write the differential equations governing the mechanical system shown in figure and draw the force voltage and force current circuits and verify by writing mesh and nodal equations. So our first step is we have to draw the free body diagram of masses present here. So from this diagram it is clear that we are having two masses, one is M1 and another one is M2, and the displacement of M1 is x1 and displacement of M2 is x2. First we are going to draw free body diagram of M1. So as usual, count the number of elements connected with M1. So here we are having K1 and B1. So only two elements. So totally three opposing forces. So the first opposing force is produced by mass M1. Second opposing force is produced by Fk1 and third opposing force is produced by your Fb1. So write the respective expressions and here the respective displacement is x1. So Fm1 should be written as directly proportional to d square x1 by dt square, which is equal to m into d square x1 by dt square. And the next one is Fk1. So and again Fk1 is directly proportional to the displacement here, and here the respective displacement is x1. Since this K1 is connected between, that is we have to assume that this K1 is connected between M2 and M1. So the respective displacement of K1 should be written as K1 is directly proportional to x1 minus x2, which is equal to K1 into x1 minus x2. And the next one is Fb1. Again this B1 is connected between, that is this is your mass M2, right? Between this mass M2 and M1 this B1 is present. Okay, don't get confused with this box. So for this B1 we have to write it as d by dt of x1 minus x2, which is equal to again B1 into d by dt of x1 minus x2, right? So again by Newton's law, that is by Newton's second law, we have to write the expression. Here there is no applied torque. So applied torque is equal to opposing torque here. So the applied torque is 0 and the opposing torques are respectively Fm1, Fk1 and Fb1. So writing the respective expressions, we will be having m1 into d square x1 by dt square plus k1 into x1 minus x2 plus b1 into d by dt of x1 minus x2, right? This is your first differential equation of mass m1. So we can again rewrite this displacement in terms of velocity. So when we rewrite, as we already know, x should be written as integral of v into dt, and dv by dt is nothing but dx by dt should be written as v, and d square x by dt square should be written as dv by dt. Just rewriting the above expression, here we will be having 0 equal to m1 into, so d square x by dt square should be written as dv1 by dt plus k1, and again this x should be replaced as integral of v dt. So here I am writing it as v1 minus v2 into dt plus finally b1 into, here we are having dx1 by dt, so dx by dt should be represented as v. So we have to write it as v1 minus v2, right? Name this expression as a and this expression b1. Now we are going to draw free body diagram of mass M2. So before going to that, just I'll explain what is with M2. So here just count the number of elements connected with M2. So to this M2, here we are having K2, B2, and there is an external force F of T. Okay, so totally 1, 2, 3, and apart from that an opposing force will be produced by this mass M2, right? So 4. Then the fifth one is just again, as I already said, this K1 is connected between M2 and M1. So we have to consider this K1, right? So this is your fifth one, fifth force. And finally again this B1 this is the friction that exists between your masses M1 and M2. So totally to this mass M2 we are having 6 forces, right? The 6 forces are namely 1, 2, 3. Opposing force produced by M2 is 4 and this is 5 and this is your 6, right? So totally 1 applied force and 5 opposing forces. So now I am going to draw this in our free body diagram of mass M2, right? So to this mass M2, here I am having, that is Fm2, Fk2, Fb2, Fk1 and Fb1. So apart from this, there is one applied force and this applied force is nothing but this is your F of t. Right. So totally there are 6 forces, right? 1, 2, 3, 4, 5 and 6. Now we are going to write the expression for each and every term. So when you write the expressions, and here the respective displacement is x2. So again Fm2 is directly proportional to d square x2 by dt square, which is nothing but m2 into d square x2 by dt square. And the next one is Fk2. So Fk2 is directly proportional to x2. So again this is equal to k2 into x2. And the next one is Fb2, and this Fb2 is directly proportional to dx2 by dt, which is equal to b2 into dx2 by dt. And the next one is k1, and this k1 is connected between m2 and m1. So here we are going to write it as x2 minus x1, which is equal to k1 into x2 minus x1. And the last one is Fb1. Again this Fb1 is between m2 and m1. So here I am going to write d by dt of again x2 minus x1, which is equal to b1 into d by dt of x2 minus x1, right? So again by Newton's law, right, here the applied force it will be equal to a opposing force. So here the applied force is F of t. So while writing F of t is equal to, the opposing forces are Fm2, Fk2, Fb2, Fk1 and Fb1, right? Just substituting the values here, we will be getting m2 into d square x2 by dt square plus k2 x2 plus b2 into dx2 by dt plus k1 into x2 minus x1 plus b1 into d by dt of x2 minus x1, right? This is our respective expression and this is equal to your F of t. Again now we are going to replace displacements in terms of velocity. So when you replace displacement, again same here, x should be written as integral of v dt and dx by dt should be written as v, and finally d square x by dt square should be written as dv by dt. Just substituting the values here, we will be having F of t is equal to m2 into dv2 by dt plus k2. For x2 we are going to write it as the integral of v2 into dt plus b2 into v2 plus again k1 into integral of v2 minus v1 into dt plus again b1 into v2 minus of v1, right? So this is your differential equations governing your mass m2, and this is your respective expression in terms of velocity, right? And now the first part of the problem is over. We have solved the differential equations governing masses m1 and m2, and the next one is we are going to draw the force voltage and force current analogous circuits, right? So here these are the general expressions in terms of velocities, and now I am going to draw the force voltage circuit. So the first one is V1 should be replaced by I1 here and V2 should be I2, and this masses should be replaced by L1, M1 as L1, M2 as L2, and this B1 should be replaced as, it should be written as R1 and R2, and this K1 should be written as 1 by C1 and this K2 as 1 by C2, right? Now I am going to draw the diagram. So here this M1 is replaced as an inductor L1, so just draw an inductor here and let this be your L1. And the next one is here we are having, that is B1 and K1, and this B1 and K1 is common for your loop 1 and 2 because here it is written as V1 minus V2. So the thing is, here B1 should be replaced by resistor R1. So just draw a resistor R1 here. And next K1 is represented as a capacitor. This is your C1, right? This is your loop 1, and let the current flowing through this loop be I1. So totally this loop consists of 3 elements, that is 3 parts, 1, 2, 3. So here this loop also consists of 3 elements, 1, 2 and 3, right? The next step is, here I am having an M2 and this M2 belongs only to loop 2, right? So here in this case I am drawing this M2 separately here. So this M2 should be replaced by L2. So just draw an L2 here. Next one is B2. B2 should be replaced by resistor R2. So just draw a resistor R2 here. And the next one is, here we are having K2 and this K2 should be replaced by capacitor C2. So just draw a capacitor C2 here, right? And the remaining things are here B1 and K1, that is B1 as R1 which is already here, and this K1 as 1 by C1, this is also already present here, right? So the next one is, here we are having f of t, and this f of t should be replaced by a voltage, that is f of t should be replaced by an e of t. And so here I am drawing a voltage source, right? And this voltage source belongs only to this loop 2. So this forms your loop 2 here, and this, let the current flowing through this loop 2 be I2, and our current always flows from minus to plus. So here you have to write it as minus plus, and this is your source voltage E of t, right? So this is our force voltage analogous circuit, and this to this second loop totally we are having 6 elements, 1, 2, 3, 4, 5, 6. And this second expression also will consist of 6 parts. Just count it, 1, 2, 3, 4, 5 and 6, right? Now I am going to write the expression here. So while writing the expression, consider loop 1. In loop 1, that is L1 into di1 by dt plus again here R1 into, through this R1 we are having 2 currents flowing, I1, I2. So I have to write it as I1 minus I2, and again the current here is 1 by C1 into integral of I1 minus I2 into dt, which is equal to 0. Okay, this is your expression for your loop 1. Now again consider your second loop. For this second loop, just consider the elements here. Again we are having R1. So for loop 2, right, R1 should be written as R1 into, again as we are considering loop 2, we should write I2 first. So I2 minus I1, okay, this is your first expression for R1. And for this capacitors, again 1 by C1 integral of I2 minus I1 into dt plus, and the next one is L2. So for this L2 into di2 by dt, and again for this R2 it is I2 into R2, and for C2 1 by C2 into integral of I2 into dt, and this entire expression, this entire voltage is equal to your source voltage here, so just nothing but your E of t, right? So this is the respective expression for your force voltage analogous circuit. Hope you all are clear with this, right? The next one is, I am going to draw the force current analogous circuit. So for this force current analogous circuit, as usual, the first thing is you have to consider these two basic equations. So again M1, M2, B1, B2, K1, K2, V1, V2, and finally this f of t. F of t will get modified as I of t here because we are drawing force current circuit, and this M1 should be replaced, this should be replaced by a capacitance, so C1 C2. For B1 it remains as such R1, and for B2 R2. For K1 it is 1 by L1, and for K2 it is 1 by L2. V1 remains as V1 and V2 remains as V2. Okay, this is the modification in force current analogous circuit. So the first thing is, as I already said, the elements which are in parallel should be connected in series, and elements which are in series should be connected in parallel. So here we are having two loops. So for this current analogous circuit, we will be having two nodes. Okay, so just mark it as one is node 1 and let this be node 2. Let this be V1 and let this be node V2. So here for this loop 1 and loop 2, the common elements are R1 and C1, and this R1 C1 are connected in series here. So we have to draw these two elements in parallel. So here when you draw elements in parallel, this resistor will remain as such as resistor. So just draw the resistor as such. And here the next one, this capacitor will get modified as an inductor. So just draw an inductor in parallel. And these two elements are between node 1 and node 2. So let this be R1 and let this be your L1. Right. And again to this node 1 we are having an inductor here. So this inductor should be replaced by a capacitor. So I am writing it as C1. So again from this loop 1 we are having three elements. To this node V1 also we are having three elements connected. 1, 2 and 3. Okay, that's it. And the second one is, consider your loop 2. So to this loop 2, again here we are having these three elements connected in series. So I have to draw these three elements in parallel. So this L2 should be replaced by a capacitor C2. So just draw C2 first. And the next one we are having R2. So just draw an resistor R2 as such. Next one you are having a capacitor C2, and this C2 should be replaced by an inductor L2. Right. Next one is, here we are having a voltage source, and this voltage source should be replaced by a current source here. So this is your current source I of t. Right. So just count the number of elements present in your loop 2. 1, 2, 3, 4, 5, 6, and similarly to this node V2 also we are having 6 elements. Just count 1, 2, 3, 4, 5 and 6. Right. Now I am going to write the expressions for node 1 and for node 2. So when you write expressions for node 1, here we have to write it as, the first one is for C1, I have to write it as C1 into dV1 by dt plus, and the next one is, this R1 is connected between V1 and V2. So here I have to write it as V1 minus V2 by R1 plus, and for this inductor I have to write it as 1 by L1 into integral of V1 minus V2 into dt, which is equal to 0. Right. So next one is, I am going to write expression for node 2. So for this node 2, again write as usual. So here in this case this R1 is between V1 and V2. So while writing expression for R1, I have to write it as V2 minus V1 divided by R1 plus, again 1 by L1 into integral of V2 minus V1 into dt plus, and again for this C2 I have to write it as C2 into dV2 by dt, because this C2 is connected only with V2. And for this R2 I have to write it as V2 by R2, and for this L2 I have to write it as 1 by L2 into V2 into dt, that is integral of V2 into dt, and this entire equation should be equal to your I of t here, and this is your I of t. Right. Here comes the end of the problem. I hope you all had understand well. If you have any doubts, let me know in the comment section. Thank you.